Hello guys. So as per our accord, we are here to discuss this unique paths problem. And this problem is basically a very interesting problem. And in this problem, I will demonstrate how to solve these unique, grid kind of problem where you'll have to find a path in the grid. So let's, just go through the problem statement, and we have been given one example, and I'll demonstrate on this example that what is the idea behind, the solution of these problems. So let's just read the problem statement. There is a robot on an M cross N grid. So let's say M is the row and N is the columns, so M cross N. So this is the M cross N grid. The robot is initially located at the top left, at this position, top left. There is grid 0, 0. Robot tries to move to the bottom right corner, this corner. The robot can only move either down or right at any point in time, either down or right. So the robot can only go down and right, down and right, down and right. Okay. So from this position, the robot can go here or it can go here. From this position, it can go here or it can go here. So at this cell, the robot can come from here or it can come from here. Okay. Okay. So, So in this problem, if you see, this is a lot like, our climbing stairs problem, but it is kind of two-dimensional version of this climbing stairs problem. So we will try to solve this problem. But before, trying to solve this problem, we need to have one observation. And what is that observation? See, it is mentioned that from any cell, the robot can go either this or this way. Either it can go right or it can go down. So if the robot is here, it can either go here or it can go here. Okay. But it can't go, anywhere outside this grid. So to reach this, this cell, this 0, 1 cell, okay, the robot will come only from this side. To reach this cell, it will only come from this side. To reach this cell, it can only come from this side. But to reach this cell, it can come either from this cell or it can come from this left cell. So all these cells, these top row cells, the robot can only come from their left cells. And all these, first column cells, the robot can only come from their upward cells, just, the cell which is just up the, given cell. Okay. So we will try to solve this problem. Okay. So with this observation, since, all these, this column cell and this row cell, the robot can only come from either left or from upward cell. But in these cells, it can come from either this cell or this cell. Okay. So with this observation, we'll try to solve this problem. Okay. So now, first of all, we need to, create one array. Okay. Array, yeah, two-dimensional array to represent the grid. And so grid has m rows and n columns. So this is what we want to have in our grid. Now, suppose we are traveling the, 0th. Okay, so array of 0th row, ith column, because then, all these places we can only come from their left cell. So 1 is the only possible value, it is there. And then int I is equal to 0, I less than m plus I. Now in this, I 0. So this is the first column. Okay. First column, all the values of the first column. So in these first columns also, we can only come from either their top cells. There is no other way to come from any other cell. Only the cell which is just up the given cell in the column, we can come from only that cell. And now for any other cell, how we can come? So we have covered this row and we have covered this part. Now we are left with this part. Okay. So for this part, the value of I will be I is equal to 1. I is less than equal to, we are taking the row and then I plus plus, we can do like this, always better to do like this. Okay. And then for int j is equal to 1, j is less than n plus plus j. Now, r of I j. So we can come to this cell either from, upward. So upward, how to represent this upward thing? I minus 1, same column. So j will be the same. Or we can come from this cell. So this will be I j minus 1. Okay. And with this, we will fill up all these values. So whatever we get at this point, that value we have to return. I minus 1, m minus 1, m minus 1. So if you observe, this problem is very, very similar to that climbing stairs problem. I would say that this is just a two-dimensional version of this problem. Accepted. Done. Done. So this is the way to solve this problem. Let me know if you have any doubts. Post it in the comments. I'll definitely answer them. Thanks a lot. Thanks a lot.